This is video number 816, Quick Start Part 0.3. In this Part 0.3, we'll talk briefly about the configuration memory, which controls the cab number the mini panel operates at, plus several other setup variables. In the original Part 2, in the original year 2016 video, we discussed configuration memory in more detail. Here's our configuration settings as we're using them in 2026. And these you don't change them very often. You may set it up once for the way you need it and not have to change it again. Over here are the defaults for these, and what we're talking about is memory addresses 0 through 5, which is what's tabulated here. I believe it says in the reference manual the addresses 6 and above don't do anything. So we're mainly concerned with these 6 addresses. And again, our defaults are over here. And most of the time we're keeping the defaults except for 2 of them. And let's go into detail. The memory address 0, the default is 3. Which means the cab bus address is set to 3. And you need this to be 3 for the power cab. Since I usually use this thing with the power cab, most of the time I have to leave this set to 3, but this could be a different address if you're using it with a Power Pro. And in this debounce timer, we just leave that set to the default. This format display unknown commands, we leave that set to the default of 0. This is the default 5 here. Now I've shown in red what we're changing, and memory address 3, we're changing that to 1. The default's 0, and that means the memory's not continuous. If we change it to 1, that means we have continuous memory for inputs 1 all the way up through 31, and that's the way we pretty much always want it for automatic control stuff. If you're doing multiple push buttons for yard routing, not automatic controls, you might use something else here, but for our purposes we want to put this at 1, so memory is continuous for inputs 1 and above. Now the other one we want to change is memory address 4. And that's defaulted to 0, which means all 30, approximately 30 inputs look for external inputs, like you could in theory have 30 push buttons hooked up to the thing, but we're usually only using 1 push button. So what we want to do is disable inputs 2 and above, and that's what setting this to 2 does. It disables inputs 2 and above. It works better if you disable the inputs you're not using. So, and again, with the programs I've been using, I have a push button on input 1, so I can't disable that, but I can disable inputs 2 and above. And the inputs will still get looked at if you're using a skip command or a wait statement. So they still work for the programming, but it won't be looking for input from push buttons and stuff. The only time you might want to change this if you need more push buttons. In one of the programs, I had 3 push buttons. So in that case, you would set this thing to 4 and disable inputs 4 and above for 3 push buttons. And in memory address 5, we just leave that to the default. And when we recorded this video originally in 2023, we used some different values, which you'll see referred to later in the video. But this is what we're using in 2026. We're declaring this to be the end of this part 8/10 video. There is additional footage in this same section where we try to discuss parts of the technical reference manual, but you may not want to watch that right now. if you actually want to review the configuration settings in your own mini panel using a Procab, Section 3 of this same video that you're now watching tries to demonstrate that. Section 3 starts somewhere about the 11-minute point. Video Part 2 of 10 in the original year 2016, video number 816 Getting Started series, also demonstrates setting configuration memory, and that's at about the 31-minute point of that Part 2. You could skip watching this configuration part for right now if you wanted to. The only thing you need to keep in mind is that for the next 5-line demonstration program in the next section where we run the train, we've set the configuration memory location 3 to a value of 4, so memory will be what is called continuous for inputs 4 and above. That is to say, commands will keep executing from one input on over into the next input. If we had not set it to continuous, we would have had to add a link to input 5 type statement to the program to get it from one input to the next. And also, less critical at this point, we've also set the configuration memory location 4 to a value of 4, so that inputs 4 and above will be what is called disabled. That is to say, they'll only be checked by the mini panel during a wait or a skip command, but this part isn't really critical to the demonstrations, but knowing about this continuous memory having happened, that is. We'll talk briefly about the configuration memory. We'll try to keep it brief. Once in a blue moon is pretty how often you have to worry about the configuration. So far we've been talking about, I guess you call the operating memory. We talk about 30 inputs, 4 steps per input, 120 commands. That's the normal memory you operate from and program from, but you also have this configuration memory that you go into once in a while to configure the thing. And there's a couple important ones, and I'm on page 3 of the mini panel technical reference manual. The writers at NCE can probably explain this better than I can, so I'm just using their work. It just says location 0 cab bus address. This is the cab bus address used by the mini panel. The default address is 3, and remember it's got to be 3 when you're using it with a power cab. If you're using it with a Powerhouse Pro, or you're daisy chained on a power cab system, you can put it to something else, but it's got to be 3 if it's plugged into the power control panel like we were earlier. Now here's an important point. Setting this address to 0 will reset the mini panel to factory default. So if somebody gives you one that somebody's already been experimenting with, you can set the address to 0. It doesn't really set it to 0, but you put in a 0, and that'll set it to default. So the address will be 3, and all the commands will be end statements. And then going down here, continuous memory, this is important. It says you can write fairly long sequences by constructing strings of 3 commands followed by a link to another string. This is inefficient that only 3 out of 4 command locations actually control anything. So we can, it says here, configuration memory 3 can be programmed with an input number above which memory will be considered continuous, and that's what we do. I think we've got it set here to be continuous 4 and above. That means inputs 1 through 3 could be push buttons, and then 4 and above would be operating. 4 through 30 would be operating memory. And then down here it's talking about disabled inputs. It says configuration memory location 4 can be programmed with the input number above which electrical status of those inputs will be ignored. And I usually disable 4 and above, the same as when I make continuous memory. These, you probably end up making these the same, but not necessarily. I normally, I think in that experiments for video 816, the original ones, we disabled 4 and above, and we had continuous memory 4 and above. A lot of my recent videos, I had to use just the first input for a push button, and everything 2 and above is continuous and 2 and above is disabled. Here's the programming sheet for the original video 816 getting started, and these are our configuration memory addresses 1 through 6, and we use the default for memory address 0, 1, and 2. Memory address 3, which is continuous memory, we change that to 4, the default 0. Memory address 4, which is the disabled inputs, the default is 0, we change that to 4. And then the rest of the stuff we let alone. I don't think these upper memory locations are even used. The important one is 3 and 4, and 0 if you're changing the cab address, which you probably won't need to for a while. All right, let's go in and take a look at these configuration memory variables if we can. So we got our menu up here, normal menu. We'll push 1 for setup like we've been doing, but previously we've always pushed 1 for input. Now we're going to push 2 for configuration. So I pushed the 2. Now that gets us to our first thing, set panel configuration cab address 3. So we want to leave it at 3. Again, just to repeat what we said earlier, if we want to reset this whole thing, we enter a 0 right here, and that'll set everything back to the defaults, including setting the address to 3 if it was something else. At any rate, let's push enter and proceed to the next one. There's memory address 1, enter, it's set to 5, we'll leave it that way. Memory address 2, enter, set to 0, we'll leave it that way. Now memory address 3, this is an important one, this is our continuous memory. We'll push enter, and it's set to 4, so we'll leave it at 4, but it could be, if we want to change it for something to something else, here's where we do it. Now we'll push the enter key again, memory address 4, here's the one for the disabled inputs, that's set to 4 also, and again, we'll leave it that way, but if we wanted to disable inputs, say 5 and above, we'd put in a 5, or if we wanted to disable inputs 2 and above, like we've done for some of the latest videos, we put in a 2. So we'll just put enter to leave it the same way. Now memory address 5, that's a 0, that's a default, and all this stuff above I think is all set to 0. We don't even use it, and not sure the mini panel even uses it. So we do a program escape, and we're back to our main menu to either do more setting up or to test or whatever. So that's how we get into the configuration memory and look at it and change it if we need to. You can skip the rest of this video if you like. It's an attempt to further relate the configuration settings for the continuous memory and disabled inputs we just looked at to the blink the LED example we used in the previous part of this video, and the run the train demo we'll use in the next part of the video. Now we'll try to show how these configuration settings that we just set affect our operating memory. Here we've got a representation on paper of the input. You can see it starts at input 1 and goes down to about input 9 before it goes off the paper. And we actually have 30 of those inputs. We've got inputs 1 to 30 to work with, and each input has four steps. And you can see input 1, it shows steps 1 through 4, the next one, and so on. And what we're seeing here is a paper representation of what's in the mini panel's operating memory. We have to actually type these commands to get them into memory. And as mentioned, we have 30 inputs to work with, 4 steps per input. And we're ignoring input 31, where those 4 commands are executed upon startup. Now let's talk about the defaults. When the mini panel is new, or the address has been reset to 0 to get it back to the factory defaults, the default is every location is filled with end statements, as shown at the left. And you can see what we've got here from starting at input 1, step 1, we've got end statements in every location. That goes all the way down through input 31, I believe. And those are basically terminate statements, so they just stop everything. And we really can't have an empty memory location because there's an end statement in there as it comes from the factory, and then we write stuff over top of it. So it's either going to be an end statement as it comes from the factory or whatever we've put into it by typing something in to, put a new command in place of that command. And the default is all the memory is non-continuous. That means it only executes 4 commands for each step and stops. In other words, if we write lines here, commands, it won't go into the next input. It'll execute these 4 and stop. That's what the red line indicates. And this one will indicate it'll execute 4 and stop. So we could have push buttons hooked to each of these inputs and do up the 4 commands for each push button using the default settings. And all the inputs are enabled, which means we could hook push buttons to all inputs. As shown here, we've got push buttons on inputs 1 through 9. This could go all the way down through input 30 with the push buttons. A minute ago when we were working with the cab, we set configuration memory location to 4, and what that did, set the memory to what is called continuous memory for inputs 4 and above. In other words, commands will keep executing from one input to the next input, and that's shown by the red line here. It's still non-continuous from the first 3 inputs, but for input 4 and above, commands will just flow from one input to another input continuously. And the default is non-continuous, and people may keep it this way for building yard control panels to control turnouts. I'm not sure. But as represented by the red line, we have set inputs 4 and above to be continuous, the red line here. And as we said, continuous, when it's continuous, commands flow from one input to the next input. For example, the command 7.1 through 8.1, and that's a demo we'll do in the next section, but we have 5 commands, and they'll just flow continuously for these 5 commands, even though the last one is in a different input. If we put that same set of commands up here where memory was non-continuous, we'd have 4 commands. Well, we'd have 3, but then our 4th command would have to be a link to input 3 to get it over the next input. Then we have to finish it here. So basically, we only get to have 3 real commands. We have to use a link statement to get to the next one. So it's less efficient for long programs because you got to keep using these link statements. For demo 1, which we did in the previous section, it wouldn't have mattered whether memory was continuous or not because it only required 3 commands, so it didn't matter if we had continuous or non-continuous memory. Also, previously when we were working with the cab a few minutes ago, we set configuration memory location 4 to a value of 4, and that controls which inputs are enabled versus disabled. And what this did, setting it to 4, that made it so inputs 4 and above what will be what is called disabled. And by that, it means those inputs are only checked by the mini panel during a wait or a skip command, and that's shown by the green line here. There's our green line, so they're still enabled for inputs 1, 2, and 3, but they're disabled for inputs 4 and above. And if they're enabled, the mini panel will essentially pull those inputs. That is to say, if it's idle, it'll be looking for a push button to be pushed. If those inputs are disabled, the mini panel will not look at those inputs except for a wait or a skip command. And said another way, disabled inputs 4 through 30 will be examined only at the time they are specifically queried by a command, such as, for example, wait till input 14 goes to ground, or skip if input 16 is open. And we might mention also test programming mode versus normal run mode. When operating in the test programming mode like we've been doing so far, the radar blink the LED demo in the previous section, in our run train demo, which will be in the next section, the push buttons will not work in the test mode. But we can use test input 4 or test input 7, for example, to test any input from 1 to 30. Basically, we can use our Procab and give a test input command to substitute for push buttons. And just as a side note, you could run the mini panel in the test mode practically all the time for your own layout, except you'd have a Procab tied up because it would have to be in the programming port all the time. But to have a push button work, which you'd want for a public display, you'd need to get into the normal run mode. In some of the demonstrations in the original 2016 Part 3, that's not just new Part 0.3, but the original Part 3, we'll hook up a push button and use the run mode for some of those demos.